Okay, let's do the 14th problem. That is limit sine ax by sine bx where a comma b not equal to 0. Okay, and limit x tends to 0. Now if you apply the value of 0 in both the sine ax and bx, it becomes indeterminate form. Okay, sine 0 upon sine 0. So we have to change this using the theorems. Now we know that there is a theorem that is limit x tends to 0 sine x upon x is equal to 1. Okay, so let's change this so that we can use this theorem. Now you see, this theorem is proved by a theorem called sandwich theorem. Sandwich theorem. Okay, so according to that, sine x upon x when x is approaching 0 will be 1. But if this is in some other form, that is sine ax upon bx and limit x approaching 0, even if you apply 0 here, this becomes 0 upon 0. See, sine 0 and 0, this is also becoming 0 upon 0, but this is proved to be 1 using the sandwich theorem. But since, and here, if because the angle here and the denominator are different, you see, a and this is b, so this is considered as indeterminate form. Okay, now let's come into the problem. Okay, now see, so let's convert this and change this for using this. So now you see, let's divide and multiply the numerator and denominator. Okay, let's divide and multiply the numerator by ax and this one by bx, so it become limit sine ax upon ax multiplied by ax 1 divided by sine bx upon bx 1 divided by bx. Okay, limit x tends to 0. Now you see, this x and x get cancelled. Now these are two constants. This can be brought out. That is also using another, there is another theorem for that. That is x limit x tends to a k f of x. When k is a constant and k can be, and this can be written as k limit x tends to a f of x. Okay, this is another theorem. The constants can be brought out of the limit. So in the same way here, we bring the two constants, that is a and b, out of the limit. Okay, so it can be written as a upon b limit x tends to 0 sine ax upon ax by sine bx upon bx. Now again, we can split this limit for to the both numerator and denominator. That is also a theorem, that is limit x tends to a f of x divided by g of x. These are two functions. This can be written as limit x tends to a f of x whole divided by limit x tends to a g of x. Okay, so in the same way, here the limit is split to both the numerator and denominator. The same way we can do this here also. So it becomes a upon b limit x tends to 0 sine ax upon ax by limit x tends to 0 sine bx upon bx. Now this is in the form, see, this is in the form of our theorem. See, this is exactly the same form, so we can write this as 1. Okay, so it becomes a upon b multiplied by, this becomes 1 upon this also becomes 1, so it becomes a by b. Okay, this is our answer. Now let's do the 15th problem. That is limit sine pi minus x upon pi multiplied pi minus x. Okay, now this is in the form of the theorem, that is limit x tends to 0 sine x upon x, okay, which is equal to 1. See, now this is in this form. You see, just we have a constant here, so we can bring the constant out, become 1 by pi. This pi will be brought out, then become 1 by pi limit x tends to pi sine pi minus x upon pi minus x. Okay, so if you apply the value of pi, becomes 0 and 0, sine 0 and 0, so this can be written as 1. Okay, so we get 1 by pi multiplied by 1, which is 1 by pi. That's it.